Alright, so we're going to take a look at a couple of exponential equations. First one we're going to look at is 64 raised to the 2x power equals 256 raised to the x minus 3 power. First thing we got to know is that it's an exponential equation. The way that you know that is through the fact that the x, or the variable, is located in the exponent. That's how you know it's an exponential equation. The first type that we solved with these was making both sides being the same base. So on the left-hand side, if I can rewrite 64 to be the same base as whatever I write 256 to be on the right-hand side, then what I have done is I have made this problem easier for us to solve, giving us the ability to work with these exponents instead of the bases. So on the left-hand side, 64 is actually 4 to the third power. 256 is 4 to the fourth power. How did I get those numbers? Well, what I used was I took out my handy-dandy calculator and I start raising things to a power, like taking 4 to the second power, realizing that that is 16. 4 to the third power is going to give me 64. And so that's where I start to get these numbers from. It's raising a base to a power. So if I can rewrite both of those numbers to be the same base, then I'm in business. So what I want to do here is I want to take now and I want to multiply these exponents because you have a power raised to a power. So you get 4 raised to the 6x power. And then you multiply on this side, just being careful to make sure that you do 4 times the x and 4 times the negative 3 to get your negative 12. But once you get here, this is the key to getting these problems solved. If you have the same base on both sides, you know for a fact that the exponent on this side has to also equal the exponent on this side. That is a definition of equality. If you have the same base raised to different exponents on both sides, those different exponents have to be equal. Basically what we talked about in class too is you can kind of just drop off the bases. Now it leaves us with an equation that goes all the way back to chapter 1. I'm not going to spend a ton of time solving this guy because this goes all the way back to reviewing early parts of the year. So you subtract 4x, you get 2x here, you get a negative 12 left over here, you divide by 2, and you get x is equal to negative 6. And so that is the solution to my original equation up here. So to continue this for just a second, I'm going to do just a couple quick practices of getting the same base. So let's say we had 25 to the x power equals 625 to the 3x power. If you are looking at this, let's go 3x minus 1 here. If you're looking at this, what you want to do is you want to get both sides to be the same base. On this one, you want to use 5 squared on this side, and I apologize for that too, being a little small there. And on this side, you want to use 5 to the fourth power. Again, how do I get that? If I can't do it in my head, I take out my handy-dandy calculator and I get to raising things to powers. Once you've got this, again, it sets up perfectly. You multiply the 2 times the x right here, you get 2x. You multiply the 4 times the 3x here, you get 12x minus the 4 also times the 1 gives you minus 4. So now you have the same base on both sides, just like you did here. If you get to one on the test and you end up seeing something that already has the same base, let's say for instance e to the 4x power equals e to the, let's say negative 2x minus 7 power, then please do not try to do anything weird with this. Notice the bases are the same, just like here and just like here. All I'll have to do is, like we did on the first one over here, is set the 4x equal to the negative 2x minus 7 and solve this equation. This one actually would give you a little bit uglier answer than the other one we did just a second ago, but you would still end up solving this exactly like we did earlier in the year, adding the 2x and then dividing by the 6 to get the negative 7 over 6.